we've learned a few things in trigonometry, basic results, and if I'm allowed to believe, all of you recall all the results that I've communicated to you, either through problem solving or in my classes, regular classes. Let me customize those results towards a triangle. Very specific results applied in a triangle, and trigonometry of triangles would be my focus in the class today. Right? Now, see, if this is a circle and there is a triangle which the circle circumscribes. So this is the circumcircle. This is the circumcircle of triangle ABC. Now, it is customary to call the side opposite capital A as small a, side opposite capital B as small b, and side opposite capital C as small c. That's a convention. That's a convention. Side opposite capital A, this side BC is referred to as small a. AC is opposite capital B is referred to as small b, and AB opposite C is referred to as small c. Right? Small a, small b, small c are sides of this triangle. Now, the center of the circle O, the center of the circle O is called the circumcenter. Hop in, hop in, hop in. So this is a triangle ABC, like I said. Side opposite to capital A is referred to as small a. Side opposite capital B is referred to as small b. Side opposite capital C is referred to as small c. This is the center of the circle circumscribing the triangle. This O is called the circumcenter. This O is called the circumcenter. Of triangle ABC. Circumcenter of triangle ABC means center of the circle circumscribing the triangle. Center of the circle circumscribing the triangle. Now, let me join B and O and produce it to meet the circle at D. Produce it to meet the circle at D. Then BD essentially will be the diameter of the circle, right? BD is the diameter of the circle. And is called 2R, where R is radius of the circumcircle. Often referred to as circumradius, often referred to as circumradius. Right? Now, let me join D and C. Then this is a semicircle, yes or no? This BCD, this arc is a semicircle because this is the diameter, right? And what's angle in a semicircle? A right angle. That means this angle, angle BCD is 90 degrees. Angle BCD is 90 degrees, right? And this angle, like I said, is capital A. What would this angle be? Capital A. Angles in the same segment. Angles in the same segment of the circle, right? Now, do you realize that this is small a and this is 2R? This is small a and this is 2r. A by 2r is sine a. Yes or no? Look at this right angle triangle BCD. Small a by 2r is sine a. Yes or no? In this triangle BCD, this is the perpendicular, this is the hypotenuse. So small a by 2r, this is 2r, BD is 2r, right, is sine a, isn't it? A by 2r is sine a. Right? This means A by sine A is 2r. A by sine A is 2r. That means, let's interpret this result. What is A? A is this side. Small a is this side. What is capital A? Angle opposite to small a. Angle opposite to small a. So which means any side by sine of the angle opposite to it, any side of the triangle divided by the sine of the angle opposite to it would be a constant and will be equal to twice the circumradius. Will be equal to twice the circumradius. That means, extending this result, B by sine B must also be 2r and C by sine C must also be 2r. Yes or no? That means A by sine A is B by sine B is C by sine C. Each will be equal to twice the circumradius. Each will be twice the circumradius of the triangle. This rule is called the sine rule. Each side of the triangle then is proportional to the sine of the angle opposite to it. Any side divided by the sine of the angle opposite to it will be equal to twice the circumradius of the triangle. Yes or no? Right? Now, can I wipe this off? Clear? Now, look at this triangle ABC. This side, like I said, is small a. This side is small b. And this side is small c. Now from A, I drop a perpendicular onto BC, BD. D is the foot of the perpendicular from A onto side BC. Now, look at BD. This is C. This divided by C is cos B. Yes or no? BD divided by C is cos B. That means BD must be C cos B. BD must be C cos B. Yes or no? BD must be C cos B. Look at this. DC divided by B is cos C. DC divided by small b is cos C. So DC must be B cos C. Right? That means this side small a must be B cos C plus C cos B. A, this whole thing is A. That must be B cos C plus C cos B. So any side of the triangle A is B cos C plus C cos B. Similarly, you'll be able to prove B is C cos A plus A cos C. And yeah, please. And C is B cos A plus A cos B. So if you have side A, then on the other side, you know, neither the angle A nor the side A will feature. It will be B cos C plus C cos B. If you have B, then B, either the side or the angle will not feature on the right hand side. C cos A plus A cos C. C, B and A will feature on the right hand side, but C will not feature in terms of side or angle. These results are called projection formulae. Projection formula. Right? All's good? Now, see, AD can be written as C sine B, isn't it? AD divided by C is sine B. So AD, can it be written as C sine B? Right? Now, realize BD is A minus B cos C. BD can be written as A minus B cos C. BD is A minus B cos C. And AD is C sine B. Hey, but can I say C sine B is the same as B sine C? Because B by sine B is the same as C by sine C. So C sine B is the same as B sine C. Why? Because B by sine B is the same as C by sine C. So AD can be written as B sine C and BD can be written as A minus B cos C. AD squared plus BD squared is C squared, yes or no? Right? AD squared plus BD squared is C squared. Right? AD squared plus BD squared is C squared. Pythagoras theorem. But what is so C squared is AD squared. What is AD? C sine B. So C sine B whole square or I might as well write it as B sine C whole square, right? AD I'll write it as B sine C whole square. And BD I'll write as A minus B cos C. Yes or no? Right? Now, B square sine square C plus B square cos square C would be B squared. Right? So there is A square plus B squared minus 2AB cos C. This is what happens. B square sine square C plus B square cos square C is simply B square. And then therefore I have A square plus B squared minus 2AB cos C. Right? So C squared is A square plus B squared minus 2AB cos C. How you want to read this is as follows. In this triangle ABC, this is small a, opposite to capital B is small b, opposite to capital C is small c, right? This is the angle capital C, right? Now, C square is the side. Square of any side of a triangle, C square, square of any side of a triangle would be sum of the squares of the other two sides, a square plus b squared, minus twice the product of these two sides, minus twice the product of these two sides into cosine of the angle included between these two sides. This is how you want to read. Square of any side of a triangle, c squared, would be sum of the squares of the other two sides, a square plus b squared, minus twice the product of these two sides into cosine of the included angle. That's how you want to read. Square of any side of a triangle will be sum of the squares of the other two sides minus twice the product of the other two sides into cosine of the included angle. Yes or no? That's how you want to read this. And this rule is called cosine rule. It's called cosine rule. So suppose I want to write a squared, then a squared from similar considerations would be sum of the squares of the other two sides, b squared plus c squared, minus twice the product of these two sides into cosine of the included angle a. Suppose I want to write b squared, then b squared is a squared plus c squared minus 2ac cos b. Right? This is the cosine rule. This is the cosine rule. A ramification of this was seen in the parallelogram law of vectors. Right? Yes or no? Do you all get this right? So we've learned the sine rule, where each side is proportional to the sine of the angle opposite. The projection formula, A is b cos c plus c cos b. And here we have the cosine rule, where square of any side of a triangle would be sum of the squares of the other two sides minus twice the product of the other two sides into cosine of the angle included between the other two sides. How about it? Right? Now, all's good? Now, some results consequently. Like I told you, triangle ABC, this is small a, this is small b, this is small c. I said a squared is b squared plus c squared minus 2bc cosine a. Now cos of any angle of the triangle then, as you can see, is sum of the squares of the sides b squared c squared minus a squared by 2bc. That's cosine of a. Right? Now, cos a is actually cos 2 into a by 2. Cos 2a, cos 2 theta, which is 2 cos square theta by theta minus 1, which is 2 cos square a by 2 minus 1. Yes or no? 2 cos square a by 2 minus 1, isn't it? Cos a is cos 2 theta, which is 2 cos square theta minus 1. Clear? So this cos a I can write as 2 cos squared a by 2 minus 1 equal to b squared plus c squared minus a squared by 2bc. I want to find the value of cos a by 2, that's why. right? I transpose this 1 on the right hand side, plus 1, right? And then when I add 2bc, I have b plus c whole squared, b squared plus c squared plus 2bc, which will give me b plus c whole squared minus a squared, yes or no? So when I carry out a regulation addition, I get b plus c whole squared minus a squared by 2bc, yes or no? Which is b plus c plus a into b plus c minus a divided by 2bc, right? B plus a into b plus c minus a is what I get out of this. Hey, a plus b plus c in a triangle is what? Twice the semi-perimeter. You've learned this, right? S is the semi-perimeter of the triangle, so a plus b plus c would be twice the semi-perimeter. And would you want to believe that b plus c minus a is twice the semi-perimeter minus 2a. From this, if you subtract 2a, 2s minus 2a, what would you get? B plus c minus a, isn't it? If from 2s you subtract 2a, you will get b plus c minus a, isn't it? So 2s minus 2a is b plus c minus a, right? So this is 2s and this is 2s minus 2a, 2s minus 2a. So this is 2s, 2s, and this is 2s minus 2a divided by 2bc, right? So all of this is 2 cos square a by 2, 2 cos square a by 2. So cos a by 2 then is going to be, as you can see very readily, is going to be root s into s minus a divided by bc. That's cos a by 2. 2, this 2 goes there, this will make this 4, and 2 taken common, that 4 will get cancelled. So s into s minus a by bc is cosine half the angle. See, why did I not take a minus sign here? So even though a could have been obtuse, a by 2 will still be acute in a triangle. See, a certain angle of a triangle A could have been obtuse, but half that angle will always be acute. So cos a by 2 can never be negative if a is an angle of a triangle. If a is an angle of a triangle, a could have been obtuse, cos a could have been negative, but a by 2 will always be acute, and consequently cos a by 2 can never be negative. That's why when I extracted the square root, I could conveniently reject and discard the negative sign, right? I took only the positive square root, right? So similarly on, from symmetry, I could have written cos b by 2 is root s into s minus b divided by ac, cos c by 2 from exactly similar considerations s into s minus c divided by ab. Yes or no? These are cosine half angles. These are cosine. I mean, you have to remember only one. The others you can build, right? From the cosmetic looks of the expression, you can build the other ones. You need to remember only one. How about it? Can I wipe this portion off? So, now cos theta can also be written as, this could have been rewritten as 1 minus 2 sine square a by 2. It could also have been written as 1 minus 2 sine square a by 2, right? Which is b square plus c squared minus a squared by twice bc. Or twice sine square a by 2 is going to be 1 minus b square plus c squared minus a squared by 2 bc. Right? 2 sine square a by 2 would be 1 minus this, right? Or 2 sine square a by 2, please see, this will give me a squared minus b square plus c squared minus 2bc is like a b minus c whole squared divided by 2bc. This I could have written as a plus b minus c into a plus c minus b divided by 2bc. Yes or no? This will be 2s minus 2c. This will be 2s minus 2b. Isn't it? A plus c minus b is going to be 2b less than 2s. This is 2c less than 2s. So this is 2s minus 2b. This is 2s minus 2c. Right? This is 2 sine square a by 2. Right? Sine a by 2 therefore is root s minus b into s minus c divided by bc. Again, sine a by 2 will always be positive. Right? Similarly, what would be sine b by 2? Sine b by 2 is going to be from similar considerations s minus c into s minus a divided by ac. What is sine c by 2 going to be? Root s minus b into s minus a divided by ab. That's sine c by 2. So these are half angle results. Cos a by 2 root s into s minus a by bc. Sine a by 2 root s minus b into s minus c by bc. Right? These are called half angle results. These are called half angle results. It's a one-time effort to get them injected into your bloodstream. But once they're there, you know. Can I remove the clutter from you? Now, if I have a triangle ABC, this side is small a, right? This is small c, this is small b, right? Now, do you realize if this is a perpendicular, this is, if this angle is c, this will be b sine c. This will be b sine c. Why? Because this divided by b is sine c, sine of this angle, right? So this is b sine c. What's area of a triangle? Half base into altitude. So half of A into B sine C. Right? Half A into B sine C. That means, now how do you read this? Half of this side into sine of the included angle. So area of a triangle is half the product of any two sides into sine of the included angle. Half the product of any two sides into sine of the included angle. So you could have also read this as half of A into C into sine B. Half the product of these two sides into sine of the included angle. You could have also read this as half of BC sine A or CA sine B, CA sine B. Half the product of any two sides into sine of the included angle between the two sides. That's how you want to read the area of a triangle. Half the product of any two sides you can take into sine of the included angle. This side into this side and sine of this angle, or this side into this side into sine of this angle, or this side into this side sine of this angle. That's the generalized version. Now, BC sine A. Sine A can be written as 2 sine A by 2 cos A by 2. So this is half of BC into 2 sine A by 2 cos A by 2. Sine theta written as 2 sine theta by 2 cos theta by 2, right? Now, I have half angle results for a triangle. Sine A by 2 available, cos A by 2 available, right? So this then is BC into sine A by 2, which is root S minus B into S minus C divided by BC. Cos A by 2, which is this, root S into S minus A divided by BC. Does it look familiar? This BC gets cancelled. Does it look familiar? Ron's formula, root S into S minus A into S minus B into S minus C. Right? Now, another version of the area of a triangle. See, C by sine C is 2R. Right? Any side divided by sine of the angle opposite is twice the circumradius. That means C by 2R is sine C. C by 2R is sine C. So this sine C I can write as C by 2R. So this is ABC by 4R. ABC by 4R, sine C written as C by 2R. So the area of a triangle is also the product of all the three sides divided by 4 times the circumradius. Divided by 4 times the circumradius. That's another version for the area of a triangle. Yes or no? All's fine? Shall we proceed? See, sine rule. Any side divided by sine of the angle opposite is 2R. So is sine C not equal to C by 2R? And the area of the triangle is AB, half AB sine C, for example. And this sine C I replace by C by 2R. So this will become ABC by 4R. Clear? Now, In a triangle, so this is a triangle ABC. There are three internal angle bisectors. Yes or no? And the three internal angle bisectors in a triangle are concurrent lines. The three internal angle bisectors in a triangle are concurrent lines. Right? This is one internal angle bisector, A by 2, A by 2. Right? This is another internal angle bisector, B by 2, B by 2. This is C by 2, C by 2, right? The point where they intersect is called incenter. The point where the three internal angle bisectors intersect is called the incenter of the triangle. I. Do you also understand that the incenter is also the center of the circle inscribed inside the triangle? The incenter is also the center of the circle inscribed inside the triangle. Sorry, a badly drawn circle, but right? This is the incircle. This is the incircle. The incircle has its center synonymous with the incenter. Synonymous with the incenter. Center of the incircle is the same as incenter of the triangle I, which is the intersection of the three internal angle bisectors. Now these are the 3 points of tangency. The circle touches the 3 sides, means the 3 sides are tangential to the circle, and say these are my points of tangency. D, E and F are the points of tangency. Right? So when you join I to F, will it not be perpendicular to the tangent? Yes. This IA, IF is called the radius. In radius is the in radius. This radius of the circle is the in radius. Small r is the in radius. Of the triangle. Center of the incircle is the in radius. Radius of the incircle is the in radius of the triangle, small r. It's commonly designated by small r. This is small r. This is also small r, perpendicular. This is also small r, perpendicular. ID, IE and IF are each equal to small r, radius of the incircle, in radius. Now, if BD is X, would you mind believing that BF is also X? Tangents from an external point to a circle. So, if BD is X, BF will also be X. Right? Tangents drawn from an external point to a circle are equal in length. Tangents from B, BD and BF. Similarly, if CD is Y, then will this CD not be equal to CE? That will also be Y. CD will be equal to CE, each equal to Y. Right? Similarly, if AE is Z, then AF must also be Z. Tangents from an external point to a circle, right? Now, 2x plus 2y plus 2z would be the perimeter of the triangle, isn't it? 2x plus 2y plus 2z will give me the perimeter of the triangle, which will be 2s. Yes or no? Twice the semi-perimeter. X plus y plus z plus z plus x, which is like 2x plus 2y plus 2z. Yes or no? Lost? That means twice x plus y plus z is the perimeter of the triangle, which is twice the semi-perimeter, which is twice the semi-perimeter. Which means x plus y plus z is s. Right? Hey, what is y plus z? AC? Y plus z, is it not AC? But AC is small b. Y plus z is AC, which is small b. So this y plus z I can write as small b. So could I not have said x equal to s minus b? So this x is s minus b, this x is s minus b. Similarly, y will be s minus c and z will be s minus a. Z will be s minus a. This is s minus a, s minus a, s minus b, s minus b. This is s minus small a, s minus small a. This is s minus small c, s minus small c. Which means so one thing for sure, the area of triangle ABC referred to as delta that's going to be area of triangle IBC plus area of triangle IAC plus area of triangle IAB, right? Right? That's the area of the bigger triangle ABC. What is area of IBC? Area of this triangle. This side is small a, the perpendicular is small r, right? So half of small a into small r, half of this is small a into small r, yes or no? That's the area of triangle IBC. Half of small a into small r, yes or no? So half of r into a is the area of triangle ABC. IBC. What's the area of triangle IAC? Half of small r into small b. This is small b. Half of small r into small b. So half of small r into small b is the area of this triangle. What's the area of triangle IAB? Half of r into small c. So half of r into small c. Yes or no? That's the area of triangle ABC. What is small r? Small r is a property of the triangle. What property? The in radius of the triangle. The radius of the circle inscribed inside the triangle, right? But what is a plus b plus c by 2? The semi-perimeter of the triangle. The semi-perimeter of the triangle. So delta, the area of the triangle, is small r, the in radius into the semi-perimeter s. In radius into the semi-perimeter s. The area of a triangle is a plus b plus c by 2, which is s into r. Delta is r into s. Area of a triangle is radius of the in circle into the semi-perimeter. Radius of the in circle into the semi-perimeter. That's one thing you got to remember. Delta is R into S. Right? Also, look at triangle IBD, right angle triangle IBD. Can I say that this x by r is cot b by 2? X by small r is cot by b by 2. So x must be r cot b by 2 must be x. X must be small r cot b by 2. Yes or no? Similarly, y divided by small r is cot c by 2. So this y must be small r cot c by 2. But x plus y is small a. That means x, which is this, y, which is this, must be small a. Right? So this is small r cos b by 2 divided by sin b by 2 plus cos c by 2 divided by sin c by 2. Cot written as cos by sin, cos by sin. Clear? Now I multiply. Sin b by 2 cos c by 2 plus sin c by 2 cos b by 2. So that will be sin b plus c by 2. The numerator, sin x cos y plus sin y cos x is sin x plus y. Yes or no? The numerator will reduce to sin of b plus c by 2. Divided by sin b by 2 into sin c by 2. How about it? Sin b plus c by 2 is sin 90 minus a by 2, isn't it? B plus c is pi minus a. B plus c is pi minus a for a triangle, right? A plus b plus c is pi. So this is cos a by 2. So this will become cos a by 2. So this is small r cos a by 2 divided by sin b by 2 into sin c by 2. Yes or no? Confused? So small a then is r cos a by 2 divided by sin b by 2 sin c by 2. So far so good. Small a, all of this was small a. Small a is small r cos a by 2 sin b by 2 sin c by 2. Right? Can I just remove this portion? Now, small a is 2r sin a. Small a is 2r sin a. Because small a by sin a is 2r, right? This is 2r into sin a is 2 sin a by 2 cos a by 2. Sine A is 2 sine A by 2 cos A by 2, right? But small a is also this. So equating these two, this is r cos A by 2 divided by sine B by 2 sine C by 2, right? Small a is 2r sine A. Sine A written as 2 sine A by 2 cos A by 2. And we also got small a in terms of small r. This was small a in terms of circumradius. This is small a in terms of in radius. Right? I'm equating that. So that gives me small r equal to 4r. See, this cos A by 2 will get cancelled. 4r sine A by 2 sine B by 2 sine C by 2. This is the relationship between the in radius and circumradius. In radius and circumradius of a triangle. Small r and capital R. Also notice this x was s minus b. This s was s minus b. And tan b by 2 is r by s minus b. R by s minus b. So small r is s minus b tan b by 2. That means if s minus b tan b by 2 is small r, then s minus c tan c by 2 must also be small r. So similarly, s minus c tan c by 2, and exactly the same way s minus a tan a by 2, each must be equal to small r. All's good. So a bunch of results at our disposal, few more to follow, but then even before I heap all of them in one shot across to you, let's get hands-on in terms of problem solving. There is a sheet administered upon you, and almost all problems of the sheet are within your reach given this set of results. So let's first try. Most of the problems require in the sheet either the sine rule or the cosine rule or the projection formula or combination of these. Let's get started with these problems. Alright, can I wipe this off?